Hello, hello. Good morning. Good
Good
morning.
morning.
Good morning. Thank you, Brandon.
Good
Sorry I'm
morning.
late. Good morning, Colin. Thank you, Colin. Good morning. Good morning, Brittany. Good morning, Xavier. Sorry I'm late. Thank you for indulging my lateness. Good morning, Nasrin. Good morning. Good morning. Not for Wow, she starts right. That's amazing. That all right, not forgiven. Fair enough. Good morning, Charlene. Good morning, Ariana. Good morning. Ryan, good morning, Gaia. Good morning, Brittany. Good morning, Michaela. Good morning, Alexis. Good morning, Anissa. Um, I, I'm not forgiven for lateness. Okay, I mean that's fair. I can't even. I see. I can't. Good morning, Carol. I'm gonna keep going. Carolina. I mean, good morning, Carolina. See, now I'm all. Good morning, Adenelsi. Good. Looking at. Okay. Good morning, Nasreen. Oh, thank you. Thank you. Yes, I lost my other, well, I temporarily lost. I'm just always cold these days. Okay. Good morning. Thank you. Good morning, Emily. No, I know. Okay. I mean it, but it still hurts. Not the hat. I mean, okay. Good morning. Uh, okay. You know what we're gonna do? Okay. So yes. So I wasn't here. So it's a little rocky road here. I was not here Monday. You watched the video. Thank you very much for understanding and rolling with some of asynchronous uh these asynchronous moments. What I think the best thing, I'm not even sure if this board is clear, because I wasn't here and you watched the video on Big Old Duck, which is thick. I mean, the material is thick. What I want to do, as you can sort of see from the board, I think the most efficient way to keep on track, to get me back into swing and get you back into swing with me is, let's start, and I mean this seriously. Let's start with Q&A. Like, I mean, obviously, I'm sure you can tell at this point. I could just talk. Um, I could just get right into where I think we are, and that could be helpful for some of you. But I think it might be more helpful for me to first open the floor, to any questions at all. And you know what? I'm even going to say, put them. Let's start with direct chat. I'll tell you why. I want to open I mean, I'll tell you how and why. I want to open the floor to any kind of questions at all, like the material. I mean, not any kind of questions at all, but about where we are right now. Could be like right something that we were saying right before, last Wednesday. Could be about the videos for sure. Although I've already gotten, and I appreciate, of course, I've already gotten your many of your write-ups of like what you did or did not understand the video. So I have a sense. So I was partly just gonna like come in and just like start addressing the questions in your documents, which I've done before, but I feel like it'd be even better if this time, if in direct chat, let's start with direct chat. In direct chat, you put in any question that you're concerned with right now. Oh, and including lab, including where you are, if you're working on a lab report right now, or you don't understand something that's going on in the lab. The one thing I'll say is that the more specific, the better. Like the more specific the question is, the more it'll like force me to stay, to not, go on for 20 minutes. Um, so I'm going to say, can you put some questions in the direct chat that you're confused about right now or like to see more clarification or emphasis? Could be from the video, could be from lab, could be from last week, could be about equations, whatever. But put them in the direct chat. So I'm going to pause for a second and watch the questions in direct chat, and I'll try, to get to like all of them or a lot of them, but I might go in a funny or okay, you see, you know what I'm saying. So if you could, so pause for a second, think about something you need a little clarification about right now. It's not 100% promise that I'll answer all the questions, but I think it'll us better. It'll get us back moving. And I'm hoping that if you put them in direct chat, you'll be more direct. Okay. So I'm gonna pause for a second and give you, I'm gonna say it again. I'll put in chat. I'm asking for questions from you that you need clarification, that you want and the more specific the better. Like what would it really work if you just say go over big old duck? The problem with that is, I'll do it. And like, and I don't think that's an efficient use of, so, okay, all right. So I'm looking at the chat. I'm going to put, hold on. And I'm going to wait. Like I already see a really good question, but I'm not going to deal with it until I see like a bunch and sort of see what order to go in. So wait, so I mean, pretend it's office hours. It's not, but like pretend it is, and I'll do my best. Hold on. Oh, so far these questions are really specific, and I will try to get. So far, the questions that I see, and there's like three or four of them, are like specific enough that I feel like I could get to all of them. So that's good. I'm just gonna still wait though. Um, These are actually they're really good questions so far. It's really worth waiting. And again, part of the reason I'm doing direct chat is I don't want you to think it's like a race or a competition because it's like not. Um, oh, really good. Okay. Oh, oh, okay. Oh, and can I do ask you a favor also? Some of these questions are like, how do we answer part A of question 4 from or something like that? Which is fine. I mean, if it's really specific, if it's like part A, like, please don't say to me, go over, homework 7 or something. But if you're saying like, what's up with part A of question 4 of homework 6 or something, that I might be able to manage in one period. But then if you do that, can I just ask you a favor? Who, like, all of you, if you do something like part A of question 4 of homework 6 or something, maybe if you can screenshot it and put it in this chat. I mean, I could find it, but it might be most efficient if you screenshot it or show me what you're. Okay. Oh, okay. I'm gonna wait a tiny bit more, but these are great. Like I could do a whole class on the questions that are in here right now. But I want to give you all a chance. Um, Also, there's just always this thing that, like, a lot of us get used to, that if we're not the first one to raise our hand, then like what's the point or something. So just take a minute. Um, and also I'll put up your thing that I didn't put up yet. Okay. That's wow. Okay. Okay. Give me one more second and I will. All right. I will tell you right now. Honestly, Even though, I mean, ideally, I would hear from all of you. I mean, ideally for your sake, but now there are, or ideally, I would hear from some people that like I never hear from, just so that I could like help them. But, um, but I will definitely say that there's enough really good questions now in the thing that for sure, um, we can work with this. Um, I honestly, this might end up taking the whole period, and if it does, if I, that will be fine by my point of view. Like, hopefully, each one of you will get something out of these questions. Obviously, I'll try to, like, hopefully, the way I answer these questions, it won't just be for that person that asked, and you can keep them coming. Oh, and there's a screenshot. Wow. Yeah. Oh, this is gorgeous. You guys. Okay. In fact, I want to screenshot your screen. I want to screenshot the. Hang on. I'm actually literally going to screenshot the chat right now for my future reference because it's actually really productive. So I'm going to start answering these questions. I'm going to say again, please believe that like if I start answering a question, and of course I'll read them out loud, but I won't read the names, blah blah blah. But if I start answering a question, please assume it's like not only helpful for that person or it's not only meant for that person. Also, you can keep them coming, like if it makes you think of something. Also, please assume because I'm seeing this now, you guys really are, and you're like helping me get back in the groove. These are really good questions. So also please assume that this may be the point of the whole. Like if I end up doing this the whole period today, then that was the period. And like but I don't want to make you tense, like thinking when's he going to get back to the class, like or so, and then like this may be the class, okay? And then you could tell me privately when we're done, when we're wrapping up. Honestly, you can send me a direct chat when we're wrapping up of like if you found this to be a productive use of your class time and like you would ever want to do it again or something or right before an exam or something or like not you can tell but I think that is what we're going to do right now and for okay but I'm going to try also I'm going to try to do these like not necessarily in the order. I'm going to sort of try to do the ones I can do fastest first. So so okay, yeah. So yeah, and I hope you take notes on this. I'm afraid if I start writing things down, I'll rabbit hole. So I'm just gonna ask you to write things down. So I'm gonna change the view. In fact, okay, in fact, I'm even gonna get rid of the screen share for the moment, just so this is like because it's like well, for me, it's like anyway, when I'm in a Zoom and I'm just looking at a screen that's just sitting there forever, that's not doing anything, it's kind of annoying. So bear with me for a second. I don't even remember how to do this. Um, Well, all right. Well, maybe I won't use it. I don't know. I don't know. Okay. All right. Here we go. Here we go. So one question. I had a question in the lab about finding the horizontal position. So this may sound kind of dumb, but does the downwards acceleration from free fall not apply to the horizontal axis, to the x-axis? Does it only apply to the y-axis? Is acceleration just zero unless otherwise stated? Okay, that is a super not dumb question. Uh, that is a super not dumb question. Um, and honestly, it's not that I think there's no such thing as a dumb question. I mean, I might be polite and stuff, but there are questions that are dumb. This is not one of them. Um, the answer is yes. I mean, the answer is, first of all, in lab four, I assume you're talking in lab four, there is no acceleration in the x-axis. That is a thing. Like that is like an important truth of the lab that you can assume acceleration in the x-axis is zero. You do assume, and you assume that acceleration in the y-axis is the constant acceleration due to gravity, like 9.8, which by the way, in like lectures and exam, like in the class, in theory, you can always round that to 10, the G number, or in fact, often as we get deeper and deeper into physics, you don't even use the number, you just call it lowercase g, and like but you can, when you're using numbers in the lecture, you can round it to 10, no problem. Everybody does. But in the lab, you try to be a little bit more, the measurements matter. So you might say 9.81 or something. But yes, in the lab for horizontal acceleration is 0, vertical acceleration is 9.81. And A, you are correct that it's not just like lab 4. It's like in life, in general. First of all, you absolutely, and I think, by the way, there's like 3 questions like this in the chat. I think I might be answering 3 simultaneously. It's definitely a thing where gravitational acceleration, everything we're saying about gravity and constant acceleration due to gravity, free fall, all of that is very specifically and explicitly for the vertical axis. It's a big discovery about the vertical axis, and part of the discovery is that it only applies to the vertical axis. Like an important, non-obvious point. Like, okay, so yes, in life, in general, if you're told nothing else, but you have some reason to believe that we're talking about an actual, like, real experiment on the surface of the Earth, and I'm serious about that. Like, if you're like macroscopic classical mechanics where you're standing on the surface of the earth and like, yeah, then you absolutely, even if someone doesn't tell you, you can believe that there's automatically a constant downward pointing acceleration in the vertical axis. And furthermore, you can and should assume that there is not any acceleration in a horizontal axis, that the acceleration is 0. I'm going to go a tiny step further with this, and then because there's like a couple other questions just like it. And if you have a follow-up, I see things already happening in the chat. If there's a follow-up, like I will look at it right now in a sec. But it's a really important question because especially the way, so first of all, yeah, in terms of doing lab 4, like, yeah, like you could use the same equations. Well, and in life, these equations that we're unpacking these days, these constant acceleration equations, including 1f at plus v naught t, include all those, um, they like they're true for all of life for one dimension at a time. Part of what we're getting at in lab 4 is the transition to when you have more than one dimension occurring. Yes, each one of those equations we have so far treats one axis at a time, and they are true for all axes, even the x-axis, where the x-axis there is a constant acceleration. I'm not contradicting myself, but hang on, listen to this. Even in the x-axis in life, you assume there is a constant acceleration, but it's 0. So all the equations work like one at a time separately for each axis. And in life, you assume in X or anywhere but where there's already gravity, unless otherwise told, you assume that the acceleration is 0. And the reason, and this gets us into other questions, the reason you could just assume that there's no acceleration unless you have a reason to believe there is Galileo's principle of relativity. Like like velocity, well, I'll just leave it at that for the moment. But yeah, things just continue at constant velocity, whatever it is, unless they don't, unless they have a reason not to. And the reason that they would not to is if there's something called a force acting on them, which we haven't gotten to. Like if they're being influenced by another object, which in this case so far the only other object that influences anything is planet Earth pulling on. Okay, so yeah, so the answer is yes. And like that's an important principle in physics that we actually can be comfortable assuming there's no acceleration on something, like unless we have active reason to believe that there is. Okay, wait, that's number 1. Hold on. But there was like 3 questions related to that. So 1 second. So, but yes, it is just 0 unless otherwise stated. Super important to that lab and to life. Oh, no follow-up. Great. Thank you for saying no follow-up. That's actually really helpful. But then, excuse me. But then other people ask things related to that. Let me try to say quickly, like, because then people also, I'm saying in the y-axis in lab 4, and what's in lab? And even in lab 5, I mean, whether you've gotten to it or not, yeah, you assume that in the vertical axis, there's automatically a constant downward pointing acceleration of 9.81, which we call lowercase g. But there too, is that positive or negative? A couple of people are asking. And in fact, a lot of you are asking about positive and negative signs and that decision in the chat, which I'm very proud because like that really is important. It's like actually a big deal in physics. So my first answer is you don't, we don't in life assume that gravity the 9.8 number, we don't automatically assume it's negative. We do not assume that it's negative. Sometimes it isn't. What we assume, what we believe, is that the 9.8 number always points down. Down. That is true and important. But then for each new situation, for each new problem, we make a decision, a conscious, explicit decision, whether to call down positive or negative. Again, this is Galileo's principle of relativity, and it's like really real. That the laws of physics are going to work either way. They're going to work either way, whether we call down positive or down negative. But first of all, they don't work if we choose both. Like we have to be in a perspective before we do physics, and we have to make that perspective clear to ourselves, and we have to stick to that perspective. And furthermore, even though the laws will work the same, whether we call it down positive or down negative, the computations will be different. It'll be easier one way than the other, probably. It will make a bit, and it will even make a difference in the final numbers and what, then we have to translate what they mean. So, like, computation and analysis is different depending on what choice you make. And sometimes it's like super easier versus impossible, depending on what. So, and everything I'm saying now also applies to the big old duck. Like the big old duck in Lab 4, one of you pointed out last time, they're very similar, not coincidentally. Like a lot of the issues are similar. And one of the issues that a lot of you was asking about in the chat is like, how do you deal with positive and negatives, or like in both of them? Okay, the first thing I'm saying is, oh, yes, you have to make a choice. And oh, yes, it makes a difference. It makes a difference how you're going to crunch your numbers, and how easy it's going to be. And it will even make a difference what final numbers you get. It's just that then like you translate them one way or the other. So how do you know whether to do positive or negative? For one thing is none of us, like negative numbers are harder to deal with than positives. All of us would rather use positives than negatives, all of us. We want to use as few negatives as possible. The only reason we ever introduce them in the first place is when we're distinguishing one direction from another, right? Like the negatives, people call down negative only if there's already some reason to be tracking up. I'm dead serious. In other words, I'm saying, whether you're talking about Lab 4, okay, Lab 4 or big old, let's Lab 4 or big old duck. Let's talk Lab 4 first. You shoot the thing and it falls off the table, right? The thing falls down the table. Gravity's very, very relevant. But the marble, the ballistic projectile never goes up. It's all the only direction it ever travels in the vertical direction is down. So there's no reason to get into negative signs on at all in that lab. They're just going to make things more confusing and hard and leave more room for error. I'm not saying you can't, but I'm saying advice, if you're asking, in Lab 4, I would call the downward direction positive. And I would say that the acceleration due to gravity is positive 9.8. And that's not a lie. Like that's a choice, right? That's an example where 9.8 is, because this is one of your questions in the chat. Like, don't make it negative. There's no point. The speed is, but then make everything that goes down positive, and that's independently, that's one axis, and then make everything that's like say your marble's going off the table to the right, like in your table, then make everything to the right positive. Like if nothing's turning around, if there's never, you see what I'm saying? Okay, that's in Lab 4. Like I would not use negative numbers in Lab 4. They're totally would just get in the way. There's no reason for them. And it doesn't mean you're ignoring them. It just means you're making a choice. I'm calling down positive and like right positive. Okay. Now, big old duck, little different. Big old duck in the Y direction. Again, there's like the 9.8 thing is happening. I'm talking big old duck, the homework. You know what I'm talking about. In there, I mean, I hope a homework number 6, is it? I think you can tell me in the chat. And I will look in the chat in a second because I think there's follow-ups. But in the big old duck, gravity is pulling down, but the character in the problem shoots a projectile, I forget, it shoots a bullet or whatever up, right? Now, so right away in the vertical axis, you have two directions to deal with. And granted, I'm not even saying that the thing that he shoots or she shoots like has to ever come down. I don't know if it does or it doesn't. Like that's part of the analysis of the problem. But I'm just saying the mere fact that it has an initial velocity pointing up while there's an acceleration pointing down, now you've got two different directions to deal with in the y-axis. So now something is going to be negative. Now we have to be like, there's going to be negative numbers. Either the initial velocity is going to be positive and the acceleration is going to be negative, or the other way around. Up to you. There, I would say, well, once you have to do that, for my money, like I'd probably make the down negative because it's just like more because I would because it's a habit. And but you do whatever, but there you have to make a choice. And there it might be a very different choice from the lab. Wait, one last thing, because someone else asked about the signs in the big old duck. Similarly, yes, I'll look in the question again, but I know there's a whole issue of like, do you make in the horizontal, do you make one direction positive or the other? Again, there too, the horizontal. Oh yeah, in the horizontal, I believe, in at least in the original statement of the problem, the duck, like from the minute you shoot, the duck is not only moving in a certain direction, but is also accelerating in that same direction, I believe. Right? It's like speeding up, right? So there, in that horizontal direction, I would make whatever that direction is, I'd make that positive because I don't see there's nothing going in the opposite direction. So there's no reason to introduce a negative sign. So again, I'm not saying you ignore the issue. I'm saying you just explicitly choose this way is positive and that other way is negative, and then the negatives just never come up. I don't know if that may hopefully that makes sense. Okay, I'm gonna look back in the chat again. I'm gonna try to stay on this topic before I move to another topic, like this topic of like the axes and the negatives and positives. And the big underlying principle I'm saying here, so far, with all the questions the couple of questions I've answered so far, the big principle, first of all, is Galileo's principle of relativity. It is train of thought. You may not see it quite yet, but the whole theme of what I'm saying is that in order to do the math of a problem, first we set up the problem in physics by choosing how we're looking at it, what our perspective, our coordinate system is. And the underlying real message here is we have more choices than we think. There is more freedom in physics than you would think, than I would think. But we have a responsibility to make that choice before we go any further. And it will make all the difference in the world of whether the problem is like actually solvable in an easy way or not. Also, the other theme that I'm saying is whatever's happening, whatever like happens in Vegas stays in Vegas, and whatever happens in the x-axis stays in the x-axis. Whatever happens in the y-axis stays in the y-axis. Like everything we learned in class before I sent you off and watch the videos, every equation, every principle was in application of one dimension of space. That's why the whole class begins with the homework assignment number line. Everything we're saying is about a axis of space. Of course, however, space consists of more than one axis. So as you transition to the big old duck and to lab number 4 and lab number 3, which I've still said nothing about, what you're trying to see, I mean, what we're trying to see is that as we transition from one dimension to 2 or 3, the idea is that all the physics we're learning just applies one dimension at a time. That and like it applies the same. In other words, Galileo's principle of relativity applies equally to each axis independently. Okay, so wait, sorry, I'm going to look in it. Hold on, I'm going to just like reread the questions to see if there's any more questions on this exact topic. Oh yeah, so one of the questions was, is it negative 9.8? When can we say positive or negative to G? So I'm sort of hoping I've answered that, but just because it's there again, let me summarize by saying I would make it negative when and only when there's more than one kind of direction occurring in a y-axis. If everything is going in one direction, if something is just falling, I'd make it positive. But if something's going up and down, or in any way, if there's an upward velocity or an upward anything in addition to the downward acceleration, then I would make it negative. Okay, wait. Oh, okay, cool. Someone just said this makes more sense. That's great. I appreciate it. Hold on. I'm looking again. I'm looking. Yeah, the math. Right. I understand. Yeah, yeah. All right. And then there's some questions that are bigger than others. Like I understand the concept of everything, but the math setup is what's messing me up. I totally hear that. That's and that's what we're like practicing. And I'm trying, but I'm, that's like a bigger, but hold on. I will. Yeah. Oh, yeah. Okay. Okay. In the video you made us watch, you said you could choose what's negative, what's positive. Is the same applied for free fall. So hopefully I just answered that. Hopefully. Wait, I'm just looking. Oh, oh yeah. Um, Another question that's a little bit bigger but very related is where someone's asking, what's the best way to approach the frame of reference velocity questions like the bolt A compared to bolt B? Believe it or not, right, again, so that's still more Galileo's principle of relativity. Um, I will, for that one, well, the fastest thing I could say right now, I mean, right now, when you just look at them, like, I feel like you can use your intuition and you will probably be right, especially because I know the person who's asking the question and I believe that they will be right. But just very quickly, like Bolt A, Bolt B, like if Bolt B is going 60 miles per hour compared to the Earth, like to the east, and Bolt A is going 50 miles per hour compared to the Earth to the east, then then Bolt B, when it's looking at Bolt A, will see Bolt A going 10 miles per hour. Like if Bolt A is going 10 miles per hour faster than Bolt B or anything, an Audi is going 10 miles per hour faster than a Buick, then that means from the Buick's perspective, but the Buick is like watching the like video game, like first person perspective on a video game. Like the Buick looks at itself as still, looks at the whole world as moving past it. So if there's a car that's going 10 miles an hour faster than it will view that car as going 10 miles an hour. Like exactly what you might think. It's like not a trick. The trick is that how powerful a revelation that is, or the trick is that that's not just like an illusion that's like really true in science, but exactly what you would think. If there's a car going down the highway 60 miles an hour relative to the highway, and another car going 50 relative to the highway, then the first car is going 10 relative to the second car. And that's what's happening with the bolts. Now, I've said that kind of quickly. Partly, I think the person asking the question, I believe that's what they would guess if they had the if I told them to just make their first guess. But and I think that's true for a lot of you. But second of all, I'm going to say that is Galileo's principle of relativity. And furthermore, I've given you all like three forms of it so far. I've written Galileo's principle of relativity in on three different ways in English. I the next two ways that are coming, maybe even by the end of this period, but maybe not. The next two forms, like form 4 and 5, well, form 4 will be a little bit more English, but 5 will be the math version of what I'm saying, like the equation version, where you'll explicitly see like exactly what I just said. And you'll explicitly see in the math what I think you already think. You just didn't know it was a science thing. That I, so I'll leave it at that for the moment, but trust your intuition for the moment, I guess. Yeah, is what I'm saying for the moment. Hold on. Hold on. I'm just looking more at the chats. Oh yeah, this one I think I can answer quickly too. Slightly sidebar, but my question is just a general question about the equations we need to know to use to use in the homeworks. Do we get those equations from the textbook or should we know them? That's a very fair question. The equations, so the equations you should use in the homework and then ultimately on an exam, the equations you should use are the equations that we literally ever say in class. Like once and I'll keep sort of cycling through and reviewing them like on a, PDF, on a whiteboard in a PDF or whatever. But the equations that you're expected to rely on in any given homework that's assigned, even when the homework seems like it's like ahead of where your thoughts are, the equations that the homework assume are only the equations that have been developed so far in class. You shouldn't ever need to go to the textbook and get new equations or on the web and get new equations. You're always allowed to use whatever sources you want. But I will tell you that if you write down an equation that we've never developed in class yet, then then you're not probably not doing you're actually making it harder on yourself than you might think. We, the whole idea of physics is that each next equation got developed logically from the ones we already have. Like there, so I it so we are right. So we are not expecting you to just come up with things. I mean, we're not expecting you to know things that we haven't explained yet. We're expecting that everything that has been explained can unlock further knowledge. So, right. So, I mean, I can give you a list again, if not at the end of this period, but as far as I'm concerned, so far in this class, we have hold on one second. Sorry. We have one, two, three, four, five. We really have six equations that we've developed in this class so far. Maybe seven if there was a seventh in the last video, but I'm not sure that there was. But we have six that I feel that we have said and done in the class. Two of them you can't even barely use to solve problems in the homework because two of them are like they say they're calculus links. They say that instantaneous velocity is the first derivative of position with respect to time. Another one says acceleration is the second derivative. Like those are really important, but like there's not much you like directly do with them. So there's four equations from which you do everything thus far, really. And you shouldn't actually need any more than that thus far. That's what makes this both easier to manage and harder. Honestly, to all of you. By the way, by the time you get to the exam, which I'm sure people soon want to start talking about, and we don't have a date for it yet. Don't worry, you'll have some input into the date. I'll get to that soon. Obviously, yes, it has to come sort of soon, but it won't come out of left field without warning. You'll have at least a week and a half of warning before it happens. Blah, 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 blah. But in the exam itself, there is an equation sheet right at the front of the sheet that tells you what you can use or what you there's no like you don't have to memorize and you shouldn't have to be using things that we don't already talk about in class. And if you want to get a sense of if you're starting to get worried about exams, we will talk about, but there is like the midterm exam from last semester is posted in Google Classroom. Your exam will be very similar to it. So you can totally look at that to see expectations form. Now, don't be scared. Like we might not have gotten to all the material yet. I don't even, but like if you want to see what it's like, that's what it's like. And what it's like is like three big homework sheets like stapled together, like an expectation that you'll do the 5-step method and all that kind of stuff. So it's like just problem solving. Okay, I'm getting off the topic, but you should always assume that we're believing that the equations we are generating as we go are all we need to keep generating as we go. Okay, but good question. Okay, wait, so I'm going back to the chat. Oh, wait, okay, okay. Wait. Sorry. Oh, okay. I knew this was going to happen. I'm so sorry. All right, just to ease. Okay, because someone's asking about the exam. Okay, I don't want to get. Believe me, exams stress me out almost as much as they do you. Almost. Um. So I don't want to rabbit hole about the exam right now, but to answer your, but I also don't want you to like build up unnecessary anxiety. The exams are designed. Um. They're not easy. You have to know your physics to do these exams, and you have to be learning physics and trying to learn physics to do well in the exams. But they are designed to get rid of a lot of the stress associated with exams in general. They're not designed to get rid of the stress associated with physics, but they're designed to get rid of the stress associated with exams. Hence, I'll answer this question right now because someone asked. I mean, Brittany asked, "Are they online?" Well, I don't even know what, oh, are they online? I see what you mean. No, what they are is take home untimed. Okay. Everybody, like we will talk about it, but when I say we'll have an exam in a couple weeks, first of all, I will not, the reason it's not in the syllabus exactly when the exam is because once I think we're ready for it and I think, okay, we like, it's time, which is soon, right? I will say, I think we need our exam to be like in the next couple of weeks, unless so it doesn't get too close to the final. And I'll tell you what I'm thinking about when I think the exam should be. And then you'll say, no, we all have an orgo exam that day or whatever or something, and then we'll adjust like in real, like we're going to make it at a time that pretty much works for most of you, or at least doesn't like stink for most of you. Okay, that's number one. So it's not, and then you'll have like a week and a half, 2 weeks notice, like before it's going to happen. That's number one. So it's not just going to come out of left field. Number two, once we announce an exam is coming, and it will be very similar to the one that's in the classroom. So that's how you study. You just practice that thing. Like honestly, don't now go buying a textbook. Don't just practice the practice exam, and that's the best way to study for it. But also, right, to answer your question, once I say it's the exam, it's a document that is posted on a Thursday night and then due back in Google Classroom like right before class on Monday. It's take home, it's untimed. It's really more, it's more, if you want to think of it this way, it's more of a paper presentation in a way, in terms of the way it's formatted, than an exam. It's not a sit down, crank out exam experience. It's a do rough draft, then like at your leisure at home until you like feel like it's really, and then do a final copy where everything is presented really nicely and you're showing all the process of how you solve the problems and you're using the 5-step method and you're using different colors and all that kind of stuff. That's what it is. And yeah, and the equations are given in the exam like booklet. Okay, so for what it's worth, if that helps it. So in terms of a lot of things you might be worried, there's no surprises in the exam. You'll know what it's like. You can know what it's like right now if you look into. So I will talk more about it and we will practice together for it, but it is not online. If online means synchronous, it is not synchronous. It is a take-home thing that you do in uh non-exam conditions. Okay, is it okay? Is that okay? So I'm going back to the chat, but we will maybe Brittany just tell me, did that sort of answer for the moment? Did that? But I'll go. Well, okay.
Yeah, that helped.
Oh, okay. Okay. Thank you. Awesome. Voice. She just got points for voice. Okay. Okay. So I'm going to go back to the chat. Again, I'm looking like sort of to do the ones I can do the quickest first. I see this a couple of screenshots. Well, I think one of them I can do fast. Oh yeah. Um. So there's one. One I'm pausing. Um. I might need more this question I feel like I can answer quickly, so I'm gonna, but I feel like I might be missing something. So maybe develop more in the chat. So I see a screenshot. Maybe I can even share it. I can't remember. There's a screenshot of problem 4 on the big old duck homework. Uh, and it says place instantaneous velocity in meters per second on the y-axis. So this is the problem called velocity time graph. I can't remember how to. Well, so place instantaneous velocity on the y-axis uh, and time measured in seconds on the x-axis of a coordinate system. Draw a straight line of slope -4 meters per second squared and a y-intercept of 12 meters per second. So, and the person's asking about that. Now, so in that problem, velocity time graph, I think I can screen. Well, in that problem, it might even be making it sound harder. There might be an overthinking thing going on here because it is literally telling you to make a graph, and it's just giving you the graphing information right from the get-go. So it's saying make a y-axis and an x, I mean, make a vertical axis and a horizontal axis. And it's literally saying make a straight line where the slope is -4, but the y-intercept is 12. So if it were a math class, if this were not physics, you would be just making two axes and starting a straight line at the value of 12 on the y-axis and then going down straight with a slope of -4, meaning, for every run of 1 unit over, you would like fall, you would rise negatively -4. So you'd have a straight line that's like going down with a steepness of -4 per one. That's all it's saying. The thing that might be confusing, and that's what we want you to do for that. And then I guess it asks a bunch of questions about that. But what might be confusing the person asking is maybe all the units and everything are throwing them off. If it were just a math class and there were no units, it would be what I just said, like slope 4, y-intercept 12. Like in other words, the straight line, the equation, like y equals mx plus b, would be y equals -4x plus 12. But we're just saying it's physics now. So the dependent variable could be anything, and the independent variable could be anything, but it's usually time, at least at this stage of physics. So we're saying our time axis, I mean our this axis is time measured in seconds. And we're saying, okay, we want to be measuring, we're looking at some object where we're not tracking where it is at every moment. We're tracking how fast it's going at every moment, like instantaneous velocity, not average velocity, instantaneous velocity, because that is something you could look at it every single moment in time. So we're so the this axis is in units, not of meters, but of meters per second. And this axis is in units of second. So first of all, that's why we're talking about an object that first is going 12 meters per second positively, whatever that means. Then a second later is going 8 meters per second positively, whatever that means. And then 4, and then 0, and then presumably crosses the x-axis, keeps going, right? Because it's just a straight line going for it. So then it's going like -4, -8, etc., -12. That's right. So if we were trying to picture what's going on here, it's kind of is like the thing that you shoot up in Big Old Duck or something. Let's say, uh, you can imagine this a number of different ways. One way you could imagine this is, let's say it's like Big Old Duck. You're shooting something up in the air, only you're not on planet Earth. You're like on the moon or someplace where the gravity is not 9.8, but it's 4. Like that's like you could imagine it that way. There's other ways you could imagine it too. So you have a situation here where you shot something up at 12. Its very first velocity was +12. But then from the moment it's going, it's losing 4 meters per second of velocity every second, right? 4 because it's on some other planet or something. And so it goes like 12, 8, 4, 0. And then now it's going into negatives. So what does that mean? It means it starts coming back the other way down. So now it's going -4, -8. That's what the graph would represent. I mean, it doesn't change the way you're drawing the graph, but if you want to picture what the graph is talking about, it'd be talking about something like that. And that's why I'm almost done with this answer, but I'd be interested to see in the chat if this is like what you're curious about. That's why the slope of this graph, the negative slope, -4, is in meters per second, because it's rise per run. It's meters per second. So that slope of this velocity time graph is the acceleration of this object. Just like if you had a position time graph, the slope would be velocity. Here you have a velocity time graph. So the slope is acceleration. So this is asking you to make the graph and picture some object that has a constant acceleration of -4, meaning meters per second squared. An acceleration that is pointing in the opposite direction from the way this thing was moving initially. For example, something thrown up in a gravity field. And that's why if you look at the graph, if you continue that line forever with that same slope that it told you, it would have to cross the x-axis. Eventually the object would be, it doesn't mean the object would fall below the ground because we're not talking about positions here, we're talking about velocities. It does mean that the object would eventually be coming back the other way. And that is totally what happens like with gravity, right? The reason if you throw something up like in Big Old Duck, the reason we call gravity negatives because gravity is always pulling down. So if you throw something up, it eventually comes down because the acceleration is constantly pulling it in the negative direction. I don't know if that's what the person was asking. I'm going to go back to sorry, I was about to screen share something. Let me just see. Is that what you were at? Sorry. Uh, Oh, great. Thank you, person who just said yes, thanks. Great. I'm psyched. And then the person who asked, when will the exam be due? I mean, I assume you're talking about the exam. We haven't decided yet. And I'm not trying to be weird. I can't. We will decide as a group. It'll be in a few weeks, okay? And it'll be posted before it's due. Like, and it's not posted yet. Like, you will have at least, and I can't, I may, I will tell you. We will decide as a group soon. I guess you can remind me on Monday that we'll decide. If we don't, maybe we'll decide today. What will we decide today? I'm not sure my head can handle it right now, to be super honest. But it won't be out of nowhere, and you will have input in the decision. And it's roughly a couple of weeks from now. Democracy, yeah. I mean, sort of democracy, like democracy with an electoral college. But yeah, yeah. Okay, and yeah, you can, but I promise you this, no later than Monday will we decide this. Like when I come into class on Monday, if I haven't already made a suggestion to Google Classroom or something like that, you can ask me right away, can we decide about this exam? Okay. And we will. I don't have the bandwidth for it right now. Okay. So, but yet you can assume a couple of weeks from now. Um, uh, you can also, by the way, if you guys have a Discord or a like a WhatsApp or like some kind of group chat in the background this week. If you guys want to talk in the background and come up with a decision, I'm telling you that what we usually do with midterms is we post them on a Thursday and then they're due 5 minutes, like they're due the minute you would come into class. They're due 10:50 on Monday. That's how we do them. So if you guys in the background, and we do have to have one soon, yes, because like otherwise it's like 2 minutes before your final exam, and we only have one midterm and the final. So if in the background this weekend you guys want to like come to a group decision of like when you want this thing posted, whether it's like it's not going to be this there. Look, okay, I know I'm making this so much more complicated than it. I'm not going to post the exam this Thursday. One realistic choice would be a week from this Thursday. Another realistic choice would be 2 weeks from this Thursday. Those are probably the two best choices. So I don't know why I'm making this so complicated. If you guys want in a group chat this weekend to decide whether you want the thing posted a week from this coming Thursday or 2 weeks from this coming Thursday, please have it be my guest. I'm happy with whatever. If you can all make yourselves happy with that decision, then I'm good. So it's basically those are the two reasonable choices. Not this Thursday. See, but I'm not even looking at dates. But okay, not this Thursday, but either do you want it to be posted a week from this Thursday or 2 weeks from this Thursday, and then it would be due back the following Monday. Remind me Monday to settle this, but you guys can talk about it amongst yourselves. I'm happy with whatever you decide, okay? And it is take home. And by the way, and as long as this is coming up, I'm sorry. I know it's just they stress me out as much as they stress you out. Not quite, but you'll also notice, I think you hopefully got emails from the MSRC where they're going to be holding a review session around the time for this, right? That's for real. The people that run these review sessions or do these things in MSRC are like past John Jay physics students, like they went through this before. And all they're going to do, not all they're going to do, but what they're going to do is take the practice exam from me, which right now is the exam that's sitting in your Google Classroom, like available to you. They're just going to take that exam and like go over it and get answers and all that and help you like solve it. And that's what they're going to do in the review session. And then our exam will be very similar to that. So like for whatever it's worth, first of all, I highly recommend like attending that if you can or whatever. Second of all, you'll find there's a ton of old videos where I walk through solutions to exams like that in the past. You're welcome. And they're usually called like a midterm walkthrough or MT walkthrough or something. They're not secret. They're you just have to find them. But I mean, they're all there. You get what I'm saying. Like you're I want you to be as prepared as possible. There should be no surprise element in this. It's just a question of how much you can get yourself to learn physics in time. Yeah, yeah, so feel free to figure out on your own, like whether you want it to be posted. Oh, I'm making you, I think you get what I'm saying. Okay. All right, let me go back to the chat. Um, that's a good question too. Okay, sorry. We are getting into 2D kinematic. This is all meant. The big old duck and the sorry, the big old duck and the lab 4 and lab 3 are all meant to transition us formally into the 2D stuff. That's where we're heading with this. And that's why the exam is like not tomorrow. Yes, we have to do more material before you actually take the exam. Yes, there will be more material on the exam than we've covered to this moment. So yes, there is usually 2D stuff on the exam. Um, and we still have to do that. Yes. Um, but at the same time, by the moment once we've declared like the exam is at this date or whatever, I'll be very aware of that, and I'll be conscious with you of covering the material that we need to get there in time for the exam and all that. And I will update the practice exam accordingly, the one that's in Google Classroom, for you guys and for the MSRC, to the point of the practice midterm is to indicate exactly what type of material or whatever is on the actual midterm. So if quark forbid, if for some reason, like as we're super close to the exam, if we haven't gotten to a certain kind of thing that is in the practice midterm or whatever, from last year, then I will readjust the exam and it won't be part of it and it won't be part of the practice. Like you get tested on what we learn. Now, some things we learn a lot faster than others, et cetera, et cetera. And some things we learn through videos and all of that. But right, but yes, there is 2D stuff on the exam on the one hand. On the other hand, by the time we get there, what's on the exam will be what we have done this semester together. And if I have to adjust in real time so that the exam reflects your learning rather than the other way around, I will. And I do. Um, but yes, good point. Okay. I'm gonna go back to the chat. But these are good questions. Sorry if I sound see. Okay. Okay. Again, I'm looking for the ones that I can sort of do quick. The big old duck part C. Oh, wait. I think. Wait, let me just see this. Oh, yeah. Okay. Well, right. So there's, oh, sorry, just to go circle back. There's another question. I didn't catch it, a screenshot, which is nice, about bolt A and bolt B. So I had already said some stuff about bolt B and bolt A, but this is like making it more clear what exactly like numbers you're worried about or what. So with bolt B and bolt A, like when it asks in part A, like how large or small is the gap, the distance between the bolts at time equals 2. Yeah, I guess the main insight that I will add to the other insight I said, like, yes, this is all about Galileo's principle of relativity, but what you should do before you try to crunch any numbers, you should try to figure out how much faster one bolt is going compared to the other. So, like, in other words, you're told that bolt A, you're told that bolt A is has a velocity of 0. It's dropped from rest at the beginning of the experiment. 5 seconds later, bolt B is thrust from the same height, but with an initial downward velocity of 40, right? 5 seconds later, but with 40, right? So what I highly recommend, so one you're told is going 0, the other one you're told is going 40, but that's at two different times. So what I would recommend is that you first figure out, like if you know that 5 seconds later, bolt B is going 40, I would stop and ask yourself at that moment when bolt B is going 40, how fast is bolt A going? so that you can literally compare their two velocities at that time. Now, to be honest, if you're still paying attention to me, like the reward of paying attention is, I think I accidentally already said the number before. Like 5 seconds later, the other one, bolt A, I think is going 50. Where did I get that from? Because it started from zero, and every second it's gaining 10 meters per second of velocity due to gravity. Like, first of all, that is a thing. Like free fall, in home, we round 9.8 to 10. Second of all, it explicitly tells you that in the problem. You can round, it says, assume that the rate is approximately 10 meters per second squared. So, right? So you can write that out as an equation. A equals V minus V naught over T. And if you rearrange it and solve for V, you will find that 5 seconds later, if something started from zero and if it's gaining 10 every second, it is logical once you think about it. It started from zero, every second it's gaining 10. Well, then 5 seconds later, it'll have 50. So I think at the fifth second, one bolt is going 50, the other bolt is going 40. So the one bolt is going 10 faster than the other bolt, right? Like that, I think that's the key to the whole problem. Like from the perspective of bolt B, bolt A is going 10. If that's Galileo's principle, and I'll go one step further. And now, since two people asked about it, or at least two people asked, I think that's going to be true for the rest of the problem because each of them is accelerating at a constant rate. Like I don't think each one of them is going to go the same speed for the rest of the problem, but I think that each one is going to go the same speed relative to the other because each one is gaining 10 every second. So in other words, at that moment, one's going 40, the other's going 50, but then in the next moment, one's going 50, the other one's going 60, and then 60 and 70. They're always going to be gaining at the same rate. Therefore, whatever the difference in their speeds is always going to be the same. All right, I guess I'll go one step further. The difference in their speeds is always going to be the same. The speed gap will always, that's not a thing, but you know what? That will be 10 the whole time. So now, in part A, I guess I'm answering the question here. When it says how large or small is the gap, the distance between the two bolts? Okay, so I'm not. If you're following me with the bolts, I'm saying one of them is always going 10 meters per second faster than the other. Now, what does that mean in terms of physical distance? It doesn't mean that one of them is always exactly the same amount ahead of the other. It means it's going always 10 meters per second faster than the other, right? So every second, bolt A I'm getting them too confused. Yeah, every second, bolt A is going 10 meters per second faster than bolt B. So if you're bolt, and I might be saying them backwards, but if you're bolt B watching, you see a bolt A going 10 meters per second relative to you. Like you're always, it's a video game. I mean, this is Galileo. It is a video game. It's first person video game. You are still, the world is rushing by you or rushing by you. So you are watching the world, and that world includes bolt B always going 10 meters per second from your point of view. That means every second it is 10 meters farther away from you. Like, I'm not saying it's sitting in front of you the whole time. Like, it's getting farther and farther away because it's traveling at 10 meters per second compared to you. So in 2 seconds, it would be 20 meters away farther than whatever it was at the beginning. Now, I don't remember what they were at the beginning. You might have to figure that out. Like whatever their gap was originally, you first have to figure out, then add 2 seconds to that. Okay. So I didn't like that actually isn't the answer, but hopefully that logic helps. Uh, so wait, all right, I'm going back to the chat. And again, those of you, anybody who, if I did answer your question, if you could let me know whether I answered your question or like that I didn't, that would be helpful because we're making progress here. There's another. Actually, this is almost okay. Actually, this is the big old duck part C. Okay, okay, yeah, yeah, yeah. Also, I just realized there are a couple of names in this class that are more similar than I'd realized. But what I'm really trying to say is I appreciate there's enough questions in the chat that I am hearing from some of you that I don't always hear from, which is really good, like for you and for me. And it's making me realize that some of the names are slightly more similar than I realized. All right, whatever. Because okay, here's a question in direct chat. Could I go over the big old duck part C? I don't understand the part about how there can be four roots or how to find it. Right. It's a question about how it's the same problem, but this time the duck accelerates north. Okay, right, right. No, I totally, I know what you're talking about. Um, no, that's a great question. I'm going to take a risk here. Okay. Well, sorry. I just read it to myself. No one could hear me. Someone's asking, could I go over the big old duck part C? I don't understand the part about how there can be four roots, how there can be four roots, or how to find it. Is the question, oh, it is the question about how it's the same problem, but now the duck is accelerating like the other way? Okay. I'm going to take a risk here. I'm going to assume that there is some amount of understanding of the big old duck itself, like until part C. Sidebar, I know you. One of the reasons we're doing Q&A today, and we might have to do more, is like you watched a video about Big Old Duck. I didn't explain it directly. I mean, whatever. The historical version of me, um, explained it on a video. That's not necessarily the same thing is live. I do want to warn you that that Big Old Duck, it's a big problem, right? Like, and it transitions us to 2D and almost always, you'll see if you're flipping through the practice exam, almost always there is a problem in the exam that is like that is the big old duck only like turned on its side or like is instead of a duck it's like the wily coyote. Like it may not look at first glance like that it's a big old duck, but there is always a big old duck problem on the exam. And by the way, that's true, like any problem in the exam is something that we've done even if it doesn't look that way. But anyway, so you do want to know the big old duck. So I'm going to take a risk right now and sort of, well, assume that you have some understanding of it from the videos, from the video. um Okay, well, the quick summary of the big old duck is right, here's a duck. It's going along. It has an initial velocity. It's going along some initial velocity. Then here's you down here, and you shoot up at the duck. And the moment you fire, at the moment, like the duck is somewhere over here. And the moment you fire, the duck starts accelerating. So now it's like moving forward and accelerating forward. And and somehow it gets and you fire so that you hit the duck, right? So that somehow the duck and the bullet are at the same point in space and time. And so the question is, where must have been the duck for this originally when you fired for this all to work, right? Like that's the question. And and yes, the insight of the problem, first of all, it's a two-dimensional problem, right? But the main insight of it is the fourth form of Galileo's principle of relativity, is that every two-dimensional problem is really two one-dimensional problems occurring simultaneously yet independently. Like I've never written that down yet. I'm saying that right now. That is if you understand that all the laws of physics are the same in all frames of reference, in all coordinate systems, then that means they're the same in all axes. So anytime something's happening in more than one axis at once, really it's just happening in each axis at the same time, but each axis is not affecting the other axis. Like that's a principle of the so whatever physics you know about this applies to whatever physics you know about this, and then in the end of the day, the common denominator between the two axes is time, right? Okay, the video already explained that. You already kind of know. So the way to do the problem, and that's the same with lab 4, right? The way to do the problem is to first solve for the amount of time that it would take your bullet to get to that height, to solve for that time, and then say, okay, in that amount of time, like use the y-axis by itself for that, and then go to the x-axis and say, in that amount of time that I'm giving the duck to arrive here, like how far would the duck go according to its equations in that amount of time, right? That's like how you solve it. It's still not the person's question. Oh, we have 5 minutes, but that's how you solve it, right? And you notice, and yeah, that's how you solve it. You notice when you solve for the time that the bullet would be up at that height, like independent of anything else, just the amount of time that it would take a bullet to get to that height just due to gravity, regardless of any ducks, you find that there's two different times that the bullet could get there. If you've done your positive and negative signs correctly, if you've chosen initial velocity to be one sign and acceleration to be a different sign, then well, actually, even if you didn't, but you get a quadratic equation that has two roots two times. And physically, they mean something because when you step back and think about it, if you shot something up in gravity, it's going to go up for a while until it comes back down. So there are two times that that bullet will be at that height, right? And that's what you find out. And so then you have to solve for each of those times. There's two different places that you could put the duck in order for all this to work, is what you find out in part A and B or something. So then the person in direct chat, and we have 4 minutes left, I know. The person in direct chat is asking, okay, but what's this deal with, wait, how would you have four roots? Very good question. And this is now as close as we ever come, I think. It's like a trick question in physics. I mean, it's because of this. What the question's trying to say is, look, if you get that there'd be two different answers to the regular problem, because you could hit the duck on the way up or you could hit the duck on the way down, right? I mean, like they would both be hitting the duck. And the reason that there's up and down is that the initial velocity of the bullet did not have the same sign as the acceleration of the bullet. Like the fact that the bullet's going up while accelerating down means eventually it has to come down, just like that graph that someone in direct chat asked about. Like if, right? I mean, if your slope is negative, you eventually cross the x-axis, which means you start moving back the other way. So we got two answers because the velocity and acceleration were in conflict on the y-axis. What the question in the homework is at, like part C is asking, is what if velocity and acceleration were also in conflict in the y-axis? In other words, well, if they were, if we switch the direction of acceleration on the x-axis, I mean, then wouldn't the duck eventually turn around and come back? And it would. That is true. If we gave the duck a negative pointing acceleration, then the duck would go like this. So you have a bullet that's going like this and a duck that's going like this. So that's why it would seem that we might now have four answers. This is the point of the question now of part C. If you, what you want to understand, what it wants you to understand is that anytime you have an acceleration that is in conflict with an initial velocity, there's going to be a turnaround. And if there's a turnaround, like in a case like that, then there's like more opportunity for intersection. So in part C, and there's 1 minute left. Don't be, I mean, try to follow this. Part C is wanting you to picture that there's yeah and yeah. So then it's like, wouldn't that make for four possible answers? But the reality is, no, it would not. There's still only two places the duck could be. There's still, because there's still only two times, no matter what, there's only two times that the bullet will ever be at that height. So there's only two plate, like it's two independent axes. So there's two different times it could be there. So then you plug those times into the quadratic for the horizontal, even though it has a negative sign in it, even though the duck's going to turn around, there's still going to be only two places it could be maybe one of them will be on the way back, but doesn't matter. The answer to C is no, there's still actually only two answers. It seems like there'd be four, but there's only two. But that's 12:05. I hope I got to most of the questions. Tell me next time whether this was valuable or not, but I know we all have to go. Okay, cool. Yes. Thank you for your everything. See you next time. Yes, I'm turning off the.